An absolutely beautiful evening, but it's time to go to bed. I've got work again tomorrow. This site never rests. Our wing is preparing to take its first flight. Today it's leaving Broughton and is being transported to Toulouse in the south of France. And it's catching a lift on the strangest looking aeroplane you will ever see.
Because it's shaped like a whale, a beluga whale. Look at that high forehead. It's like a normal aircraft with this huge bit attached to it. It's absolutely stunning. The company's got 5 of them, and it's used to transport various pieces of a new aeroplane to Toulouse, where they assemble all the wings and the fuselage and everything all goes to Toulouse. But just look at that, it's extraordinary. Oh, what a privilege!
The last and most critical job of loading a wing onto the Beluga is down to the team with a tiny bit of help from me.
Are you ready, boys? Yeah. We're going forward.
Yeah. Keep that on firmly, unless I shout stop, just let it go. They might have a fault with the aircraft.
You spelt forward wrong.
And I've literally only got inches on each side to play with.
Can you see how close the edge of the wing is there to the aircraft, and at the other end? This is the widest part of the wing, the root, you know, the bit that attaches to the fuselage.
This is a big plane. It's the company's workhorse. But despite its size, it can only carry one A350 wing at a time. I've managed to squeeze on board to help deliver our wing. After a 2-hour flight, the Beluga touches down in Toulouse in the south of France. It's here that Airbus receives thousands of parts from suppliers in Spain and Germany, and the construction of the aeroplane begins, just like a massive Meccano set. Our wing is now carefully unloaded and transported, ready to be attached to the fuselage of the A350.
The site here in Toulouse is 5 times bigger than Broughton, and about 25,000 people work here. But look at this. This is where they start to assemble this fantastic jigsaw puzzle. So you've got the fuselage, the main body where we sit in an aircraft. Then you've got these beautiful wings all the way from Wales being attached. You see the tail fin going in, the horizontal tail plane, the landing gear. It's all coming together, and it's all been done quite quickly. So how many Welsh boys and girls are working in Toulouse then?
We've got about 50 altogether.
Yeah.
So we've got design engineers, map engineers, also got production, operations, quality.
It's exciting, isn't it? And you, a boy from Mould,
I know.
Coming to work
yes.
in Toulouse. Did you ever think you'd end up working in something like this?
No, it's exciting times for me. I've been here for 7 years now,
yeah.
with family, and I'm still excited. I enjoy getting up for work, I know, yeah.
See how beautifully that's milled there. Isn't that lovely? It's lovely work.
It's excellent, yeah.
As Paul and I get to know each other, we realise we share a surprising link.
I did a course once on milling and lathing in Wrexham Tech.
Very good.
Yeah.
I've been there myself.
You were at Wrexham Tech?
Yeah, a long time ago. Though,
Yeah, well, I
in the
bet
80s.
mine was a bit further back than
Well,
yours.
early 80s I was there with Wrexham Football Club, and they used
Yeah.
to send us 1 or 2 days a week,
Yeah.
because it's only across the way, right next to the racecourse ground, so...
Yeah. So we operated in the same grease together then, is that right?
Yeah, mine
It was
probably a
quite
bit-
dirty then though, wasn't it? You know, when it was
Yeah.
all, and stuff spilling out
I
everywhere.
think it's gone a lot more high-tech now.
Yeah. It's a lot of inspecting to do, isn't it? From the time the wing arrives to when the fuselage comes and it's all fitted. So there were, what, 5 test planes built?
There's 5 test aircraft
Yeah.
which are on flight test.
Yeah.
So they do all the different tests that
Yeah,
they go through.
absolutely, yeah.
It's a good feat, especially when the first one of these went up last year. It was,
Did you see it?
yeah, we were excellent, yeah.
When it flew from here?
Yeah, we were all outside
First
here.
test
yeah.
flight?
First test flight, yeah.
Oh, how exciting is that?
Everyone was pushing up.
Yeah, we're all pedalling.
No, a sense of achievement, really.
Yeah.
Until this point, the A350 had never flown.
3, 2, 1, stop.
So imagine the pressure on the test pilots as the whole world looked on.
100. Check. Positive 5. Gear stays down.
Getting the chance to step inside these extraordinary manufacturing sites makes me realise just how clever we humans can be. I've been told when the paperwork accompanying the aircraft is as heavy as the plane itself, they've got things right. So, when we jump onto an aeroplane to go on our holidays, most of us just take the whole thing for granted.
This is my first look inside the fuselage. Oh, wow. That is stunning. I've never seen anything like this before. I mean, you can see the insulation, all the different coloured insulation. That's to keep us warm as passengers and to stop the noise from coming in as well. And then all the seats go in here. You can see some of the tracks already laid down. This is 67 metres long, the whole fuselage, which is, if you take an Olympic-sized swimming pool, the length of that, and then you add on about 17 metres, about 50 feet, that's how long it is. And this flies over oceans. It's extraordinary. So where are the wings? Well, they're fixed in between the doorways, so you can see here that they're front of this door. And doors to manual, and the second set. So anybody sitting here is sitting alongside the wings, and you can see them flex beautifully in flight. And the detail, I mean, everybody working on here, of the electronics, of the air, I mean, just everything is actually quite extraordinary. But this actually, first class or not, is the best seat of all. It's these. Look, hello, bonjour. These people are working on the cockpit.
Finally, our second wing has arrived from Wales and is being attached to the fuselage. To finish it off, there are a couple of very important pieces of French finesse to be added.
And here they are. These are called winglets. They're like a French extension to our Welsh wings. They're made of the same material, carbon fibre, and they make the wings look distinctive, elegant, graceful, cool, if you like. But that's not why they're fitted. You see, what happens when the aeroplane is flying, you have a much greater static pressure underneath the wing than you do on top. That's how you get lift, that's how the aeroplane rises. But the problem comes at the wing tip, because when these two different pressures of air come together, they create mini tornadoes behind the aircraft, vortices. That creates what's called drag or air friction. And what that means when you're flying a plane is that you need more power to go at the same speed. And if you need more power, you need to use more fuel.
To solve this problem, engineers turned to nature for the answers. This is a tawny Indian eagle. For millions of years, birds have been the perfect flying machines. Airbus employs engineers to study nature, to learn valuable lessons from animals and birds. It's called biomimicry engineering. By studying how this beautiful eagle flies, they have unlocked the secret to the problem of those vortices.
Isn't he stunning? Yes, you. His wingspan is around 2 metres. And he is a bird of endurance because he has to stay on the wing for hours on end looking for his prey, and he can only do that by using as little energy as possible. Now, the A350 engineers have been studying effectively the ruthless efficiency of his wings and using that natural technology or elements of it in the design of the aircraft. So we're going to use, yes we are, and you're going to behave, a slow motion camera to record him flying and then play it back to you, and you can see exactly what happens.
Dr. Norman Wood is an expert in aerodynamics who's been studying the performance of this bird to improve wing design in new aircraft.
It's magnificent.
Beautiful bird, isn't it?
Yeah, it's a very good example. Really perfect aerodynamics.
So an eagle, built for endurance, has to fly on the wing for very many hours, doesn't want to use too much fuel.
No.
Its own energy,
That's
in
right,
fact.
yeah.
And it's exactly the same principle that's replicated with the wings of the A350.
Yes, well...
Light, with a composite.
It's the very light wing. It means we can adopt some new strategies because we're now using the carbon fibre.
Yeah.
And we couple that with this more detailed understanding of the specifics of the wing shape to get the minimum drag we can. What the Eagle has managed to achieve is the perfect match between a very light, efficient structure and a very efficient aerodynamic shape, with the tips slightly turned up to reduce drag.
Just as the A350 has the winglets.
Just as we've done on the 350.
Yeah.
And you can see the similarities straight away when you see the shots of the Eagle as it comes towards us, how it mimics, well, no, we're mimicking its shape.
Absolutely, yes. It's not mimicking the A350.
It got it right several thousand years ago. It's still with us, so it must be right.
It must be right.
And as we've evolved over 40 years of Airbus wings, you can see innovations coming in, not just in the way we've adapted the shape, but going beyond that to see how the bird actually controls that shape, how it controls itself in flight. And we're now adapting those things into the wings on the 350 as well, so it reacts to its environment. Maybe not quite as effectively as the Eagle, but we're getting there.
Yeah. And when he's coming into land, flaps down.
Flaps down, wheels out.
Wheels out, gear down.
Eyes on the target.
There's a good boy. There's a good boy.
The new design of the A350 wing reduces fuel burn by 25%. And over half of that saving is by adding these small yet ingenious winglet devices. It has a huge impact on the environment, a greener and more efficient flight, thanks to the Eagle. It's remarkable to think that a whole A350 plane takes just months to build, from a jigsaw of individual parts from factories all over Europe.